Lagrange's method of undetermined multipliers means in this, the two functions are related to one to another variables. That is nothing but if we can find out any function, for that the function has, if we can find out the extreme values of the f function, it has subject to the condition pi of x comma y comma z is equal to 0. That is nothing but Lagrange's method of undetermined multipliers means in this, the function has three variables. Okay. One function f is also having three variables. Let it be f of x comma y comma z. And it has related to another function f of pi of x comma y comma z is equal to 0. Okay. In this, how to find out the maximum or minimum of this f function? That is finding if the function has related to another function. In that case, how to find out the maximum or minimum of the given function. Okay. This type of the problems can be solved or for finding of the maxima or minima by using of Lagrange's method of undetermined multipliers. Okay. In this also we can follow the working rule. First we can identify for which function we can find out the extremum, that is nothing but maximum or minimum value. And the function is related to which function? That is nothing but subject to the condition. Okay. Here, suppose it is required to find the extremum, that is nothing but maximum and minimum for the function f of x comma y comma z subject to the condition pi of x comma y comma z is equal to 0. In this, first step is form Lagrange's function or Lagrangian function. Capital F of x comma y comma z equal to small f of x comma y comma z plus lambda pi of x comma y comma z, where lambda is called the Lagrangian multiplier. Which is determined by the following condition. In this, step 2. The step 2 is obtain the equations. The same equation, dou f by dou x is equal to 0, dou f by dou y equal to 0, dou f by dou z equal to 0. The two functions we can take only first order derivatives with respect to x and y, we are equate to 0. Here the function has three variables, so we can differentiating the Lagrange's function capital F with respect to x, y, z. What are the variables are involved? Then we can differentiate partially. From this, we are getting dou small f by dou x plus lambda dou small pi by dou x is equal to 0. And it is dou f by dou y plus lambda dou pi by dou y equal to 0. Dou f by dou z plus lambda dou pi by dou z is equal to 0. We are getting this is the first equation. Okay.
Yes, ma'am.
This is second equation. It is third equation. It is fourth equation. In the step 3, solving equations, in this, the given equation is first equation. This is first equation, f and phi. Solving of 2, 1, 2, 3, and 4 equations, we are getting the points. Equations 1, 2, 3, and 4. We are getting the values. That is, the values of x, y, z. So, obtain will give the stationary point of f of x comma y comma z. Okay, that is nothing but solving of these 4 equations. We are getting the x, y, z values. Then that x, y, z value can be substituted in the function. Then the point is called as stationary point, and on that point, the function where it is maximum and where it is minimum, we can find it. Okay. If to find the maxima or minima of the function f of x comma y comma z equal to 0, it is subject to the constraints, means we can take 2 combinations. This is like this, 2 combinations, that is capital F of Lagrange's multipliers, means in that they have given the 2 functions which are in 3 variables, and we can construct the Lagrange's function. From this function, we can differentiating with respect to x, y, z partially. We are getting 3 equations. From these 3 equations, we are getting the points, that is values of x, y, z. Those values of x, y, z, we can substitute in the function. Then that is the extremum function. The point is called as the stationary point. Okay. Here we are getting only 1 point only. That at that point, the function has extremum. Okay. Is it clear?
Yes, ma'am.
Next, we can go for the problems, then easy to understand how to find out the maxima or minimum values. Okay. Find the minimum value of x square plus y square plus z square given that x, y, z equal to 8. First, you can identify what is f function, what is phi function. Then only you are getting the correct value. Here, minimum value of the function, let it be f. For which function we are taking the extremum, then that is the f function. So it is x square plus y square plus z square. Given that is nothing but subject to 2 conditions. Phi of x comma y comma z is equal to x, y, z minus aq. Okay, is it clear?
Yes, ma'am.
Minimum of function. So let it be small f given to the condition, that is the phi function. Now we can take the Lagrangian function. Okay, consider the Lagrangian function. Capital F of x comma y comma z equal to small f of x comma y comma z plus lambda phi of x comma y comma z. This is the equation 1. This is the Lagrangian function. Here f is equal to x square plus y square plus z square plus lambda into xyz minus a cube. Here f function is differentiating with respect to x. It is 2x plus lambda into yz. It is equal to 0. Here f function is differentiating with respect to y. 2y plus lambda into xz equal to 0. Dou f by dou z. Here x square y square 0. So 2z plus lambda into xy equal to 0. It is equation 2. It is equation 3. It is equation 4. Solving 2, 3 and 4. So here from this 2x equal to minus lambda yz. 2y equal to minus lambda xz. 2z equal to minus lambda xy. Okay. From this, we can write lambda minus lambda equal to 2x by yz. Here also minus lambda equal to 2y by xz. Minus lambda equal to 2z by xy. Is it clear?
Yes, ma'am.
If the constant is also taken to left side, in all the terms are there, minus lambda by 2 equal to x by yz, minus lambda by 2 equal to y by xz, minus lambda by 2 equal to z by xy. So we can all together equate one to another. Why? Because minus lambda by 2 equal to x by yz minus lambda by 2 equal to y by xz minus lambda by 2 equal to z by xy. It is equal to equation 5. Okay. Now we can equate first two terms, last two terms, and first and last. Then we are getting the
X square
relation.
equal to y square equal to z square.
Yes, the relation in between. Here
X cube, sorry.
we can take x by yz equal to y by xz. Z cancel. By the cross multiplication, we are getting x square equal to y square.
Square into y square.
Next, equate the y by xz equal to z by xy. X cancel, we are getting y square equal to z square. Okay. Here we can equate x square equal to y square equal to z square. If you can take the last two also, y by cancel, we are getting x square equal to z square. So from these two, 6 and 7. From 6 and 7, what is the relation? X square equal to y square equal to z square. From this, x equal to y equal to z. Okay. This x equal to y equal to z values substitute in pi. What is pi? X, y, z equal to a cube. So we can write either in x, either in y, either in z. So it is x cube equal to a cube. Why? Because x equal to y equal to z. So x equal to a. Okay. This is x equal to a means what is the point? X comma y comma z equal to a comma a is the stationary point. At this point, we can find out the function. Okay. Therefore, minimum of f of x comma y comma z is equal to x square plus y square plus z square, and the point is a comma a comma a. So minimum of f equal to a square plus a square plus a square equal to 3a square. It is the solution. The second problem is divide 24 into 3 parts. Let x, y, z are 3 parts. Okay. Then 24 is divided into 3 parts means that is x plus y plus z. From this, we can write x plus y plus z minus 24 is the pi function of x, y, z. Is it clear?
Yes, ma'am.
Next, the continued product of the first. Why we are taking this is the f and it is the pi means we can find out the product of first, square of the second, and cube of the third is maximum. That is nothing but let f equal to, let the first one is x is the first. Suppose y equal to second. We can take z is equal to third. What we can take the product? The first product, square of the second, and cube of the third is maximum. So, in which function we can find out the maximum? Let that function is f. And this is related to which one? That is pi. Pi of x, y, z is equal to x plus y plus z. That is the major clue here. Then we can take the Lagrangian function. Consider the Lagrangian function. Capital F equal to small f plus lambda into pi. From this, we can write capital F of x, y, z is equal to x y square z cube plus lambda into x plus y plus z minus 24. And we can differentiate with respect to x, y, z partially. Dou f by dou x equal to y square z cube plus lambda into x differentiation is 1, remaining all terms will be 0. Let it be equal to 0. Here it is equation 1. This is equation 2. And dou f by dou y is equal to 2xyz cube plus lambda equal to 0. Dou f by dou z equal to 3xy square z square plus lambda equal to 0. From this, lambda equal to minus or minus lambda equal to plus y square z cube minus lambda equal to 2xyz cube minus lambda equal to 3xy square z square. Okay. Here third, fourth, fifth. Solving 3, 4, and 5. All are minus lambda values only. From this, minus lambda equal to y square z cube equal to 2xy z cube equal to 3xy square z cube. Okay. Now we can equate. Here, equate y square z cube equal to 2xy z cube. Here z cube cancel, 1y cancel. From this, what we are getting? Y equal to 2x. Okay. Next, equate to first and last. Y square z cube equal to 3xy square z cube. Okay. Here, y square, here 3x y square z square. Okay. Here y square, cancel, 1z square, cube cancel. From this, z equal to 3x. Okay. Here, and we can take the middle, that is 2xyz cube equal to 3xy square z square. 1y cancel, 1z square z square cancel, x cancel. From this, 2z is equal to 3y. Here, z by 3 equal to y by 2 from this relation. So, y equal to 2x. From this, x by 1 equal to y by 2, we can write. Z is equal to 3x. From this, we can write z by 3 equal to x by 1. From 2, z is equal to 3y. From this, we can write z by 3 equal to y by 2. Therefore, x by 1 equal to y by 2 equal to z by 3. So, what are the variable values? X equal to 1, y equal to 2, z equal to 3. Then, these points are saddle point 1, then 1, 2, 3 is a stationary point, not saddle. It is a stationary point at which the function has maximum. Okay. Therefore, the maximum of f at 1, 2, 3 is f of x, y, z is equal to xy square z cube. Therefore, maximum of f equal to 1 into 2 square into 3 cube. 1 into 4 into 3 3s are 9, 9 3s are 27. 7 4s are 28 to 108. Therefore, maximum of f function is equal to 108. Is it clear?
Yes, ma'am.